Hello students, I'm Dr. Mamta Gautam from ABES Engineering College Ghaziabad. Today we are going to discuss the water softening process, third method, lime soda process. In the previous two lectures, we covered the two methods of water softening, zeolite process, ion exchange process. Now today I'm going to discuss third method of water softening process, lime soda process. In this lecture, we will cover the principle of this process, types of lime soda process, cold lime soda process, hot lime soda process, that are the types of lime soda process, advantages and disadvantages of lime soda process. Firstly, I'm going to discuss principle of lime soda process. In this process, all the soluble impurities, that is calcium and magnesium salts present in hard water, converted into insoluble precipitate. For this, calculated amount of lime and soda are added to the hard water. All the calcium salts will precipitate out as calcium carbonate, and magnesium salt precipitate out in the form of magnesium hydroxides. Aluminium salt precipitate as aluminium hydroxide. Iron salts will precipitate out as the ferrous hydroxide and ferric hydroxide. That is the basic principle of lime soda process. Now coming to the reactions, lime remove the temporary hardness. What is the formula of lime? That is CaOH whole twice. Calcium hydroxide, that is called as lime. Lime remove the temporary hardness. Temporary hardness, bicarbonates of calcium and magnesium. Calcium bicarbonate remove with the help of calcium hydroxide, that is lime, and it will give the insoluble precipitate of calcium carbonate. It means calcium salt will precipitate out in the form of calcium carbonate. For calcium carbonate required 1 mole, or you can say 1 equivalent of lime for the removal of bicarbonates of calcium. Magnesium bicarbonate Mg at CO3 का whole twice. Magnesium bicarbonate removed by 1 mole of lime. Lime remove the bicarbonates of magnesium. Magnesium salt will precipitate as magnesium hydroxide and release the CO2 plus 2H2O. Lime remove the permanent magnesium salt. Permanent magnesium salt means permanent magnesium salt. That is magnesium chloride and magnesium sulfate. Permanent magnesium chloride removed by lime precipitate out as in the form of magnesium hydroxide but this reaction generate the permanent calcium salt. calcium chloride. This is the permanent hardness. Permanent hardness only removed by the soda. Calcium chloride removed by the soda, and soda formula is sodium carbonate. Again, calcium carbonate insoluble precipitate and removal of 2NaCl. It means permanent magnesium salt removed by lime and soda. Temporary hardness removed by lime. Permanent magnesium salt removed by lime and soda. Similarly, as magnesium sulfate removed by lime, magnesium hydroxide precipitate, as I told you before, magnesium salt will precipitate out in the form of magnesium hydroxide and generate the permanent calcium hardness. Permanent calcium hardness is only removed by soda. Calcium sulfate react with soda, Na2CO3, calcium carbonate insoluble precipitate, and removal of Na2SO4. That is permanent magnesium salt removed by both lime and soda. Permanent calcium salt, calcium chloride, and calcium sulfate. Calcium chloride react with Na2CO3. Na2CO3 is soda. 1 mole of calcium chloride removed by 1 mole of sodium carbonate. It means 1 mole sodium carbonate is required for the removal of calcium hardness. Insoluble precipitate of calcium carbonate and remove the 2NaCl. Similarly, as calcium sulfate react with soda, Na2CO3, again it will give calcium carbonate insoluble precipitate and removal of Na2SO4. Permanent calcium salt is removed by only soda. Now I am going to discuss types of lime soda process. They are of two types: cold lime soda process and hot lime soda process. Cold means at room temperature. To speed up the precipitation, added some coagulants, because at room temperature fine precipitates are obtained and they do not settle down easily and cannot be filtered. For this, we add some coagulants like aluminum sulfate, sodium aluminate. Cold lime soda process are of two types. Number one, batch process. And second is continuous cold lime soda process. Cold means at room temperature. This reaction is complete at room temperature. Room temperature like 25 or you can say 35 degrees centigrade. Hot lime soda process. It is complete at near the boiling point. So there is no requirement of coagulant for the precipitation. Hot lime soda process is further subdivided into two types. Number one, batch process, and second is continuous continuous hot lime soda process. First, I'm going to discuss batch process. Batch process, it is also called as intermittent process. This is the diagram for the intermittent process. Here we have two inlet, one for chemicals, second for hard water. And this is the outlet for soft water. And here we are using distiller, the mixing the hard water and chemicals. And this is the outlet for the sludge. Intermittent type softener here we are using. Intermittent type water softener consists of a pair of tank which are used in turn for softening of water. At room temperature. And second is continuous cold lime soda process. And this is the diagram of continuous cold lime soda process. Here we have two inlet, one for chemicals and second for hard water. Here hard water is passed through this inlet and chemical is passed through this inlet. And this is the stirrer. This is a continuous process in which hard water and chemicals in calculated amount continuously fed from the top into the inner chamber. It means there are two chambers. This is the inner chamber and this is the outer chamber. Stirrer will start as hard water flow down and mixing takes place. Softening of water takes place in inner chamber and precipitate, that is called a sludge, settle down at the bottom. The softened water goes upward in the outer chamber and this is the wood fiber filter for the filtration. This wood fiber filter ensures to the complete removal of sludge. Filtered soft water finally comes out continuously through this outlet. That is the continuous cold lime soda process. Cold lime soda process, it is done at room temperature. At room temperature, it means that is very slow process. For the precipitation, we are using coagulant like alum, sodium aluminate, aluminum sulfate. Filtration is not easy. Residual hardness up to 50 ppm. Dissolved gases cannot be removed and it has low softening capacity. That is the cold lime soda process. Hot lime soda process, there is no requirement of coolant for the precipitation. You can see here, this is the inlet for the hard water and this is the inlet for the steam inlet. Chemicals. Here we have three tanks. One is reaction tank, second is sedimentation tank, and third is sand filter tank. Reaction tank means reaction will take place, hard water and chemicals both are mixed in the presence of heat. Precipitation will take place and after this water is passed through the sedimentation tank to slow down the speed of water, slowly filtration, and then finally we will get the soft water. That is the continuous hot lime soda process. Hot lime soda process, the reaction proceeds faster because this reaction is complete at near the boiling point. Softening capacity of hot process is increased. Precipitate and slurs form settle down easily and no coagulants are required. Dissolved gases like CO2 and air driven out of the water. Hot lime soda process produces water of comparatively low residual hardness up to 15 to 30 ppm. Viscosity of softened water is lower. Filtration of water becomes easier. Lime soda process produces water of comparatively lower residual hardness of 15 to 30 ppm. This is the hot lime soda process. Now coming to the advantages of lime soda process, it is very economical and process increases the pH value of the treated water. It means corrosion of the distribution pipe is reduced, removal of hardness. To a certain extent, iron and manganese are also removed from the water. Disadvantages of lime soda process: for efficient and economical softening, careful operation and skill supervisor is required. This can remove hardness only up to 15 ppm, which is not good for boilers. Generation of large amount of sludge in the form of calcium carbonate, magnesium hydroxide, aluminium hydroxide, ferrous hydroxide, or ferric hydroxide. These are the references. Thank you all.